Assalamu alaikum YouTubers, myself is LK and I'm here with a new lecture presenting estimation of a sewer line. Actually, sewer line is some kind of underground water pipe just used to drain sewage from residential buildings or residential area. And there are many types of a sewer pipe according to materials and the cross section of a sewer pipe. But we'll not go in detail for all these types because here in this section we are just doing the estimation of a sewer line. Say this is just a sewer line with pipe and some kind of dry budgery at the base. Here the concrete may be used just like a lean concrete, and these are some kind of ground levels, the diameter and the depth of the trench, the breadth of the trench. And this is just a sample and a typical section of a sewer line. And we'll just do estimation for the same section. Say if you are asked to estimate material for 300 feet long sewer line, the pipe length is just 6 feet. Remember, the 6 feet length just represent the length of a 1/5. Also, the sewer line has a slope of 1:200 and assume the ground is just level. Let me draw the same section a little bit over here. And this is just the pipe where the interior diameter is 9 inches. And at the base we have some kind of dry budgery. The ground level is over there. And the external diameter is just 11 inches. It means the thickness of a sewer pipe is just 1 inches. And the sewer pipe is just, of course, the trench depth is just 3.5 feet. The breadth is just 3 feet. And the cross section is taken at the middle point of the sewer trench. Let's take a look to the example terms for a moment. We are asked to estimate materials. What does it mean? What's my approach over here? My first approach will be just excavation. How much excavation do I need for the trench? And then we'll do some calculation for dry budgery. And then we'll determine the number of pipes required for the given sewer line. How many number of joints do we need? And lastly, we'll of course do calculation for refilling of the given trench. So let's do some solution over here now. Remember, my first approach is just excavation. And the excavation may be just termed as the cross-sectional area of the trench times the length. The cross-sectional area is given and the length is also given. So I need some plug and chug in over here. The excavation must be the cross-sectional area. Just look at over here. The depth is just 3.5 and the breadth is also known. So the breadth times the depth is just the cross-sectional area times the length, which is just 300 feet long. This is just the length of the sewer line. If you do some maths with all these three guys, of course you can get the excavation as 3150 CFT. So we'll excavate the trench just 3150 CFT. And my next approach, remember, it's just the dry budgery. And the same formula will be used. The budgery will be just the cross-sectional area times the length. Just look at over here. The breadth is known. And the thickness of this layer is also known. So the breadth times the thickness will be the cross-sectional area. And with the length multiplication, of course, we can get the total volume. So plug and chug in. The cross-sectional area is just 3 times 0.75. Remember, this is 9 inches, which is equal to 0.75 feet. Times the length is, of course, 300. You can get, of course, 675 CFT as the dry budgery. Here you may notice, why should I provide the total depth in this formula? Because we are not losing any depth, okay, due to compaction or any other process. And next, we need the number of pipes required for the given sewer line. So the number of pipes will be just the total length of the sewer line divided by the length of one sewer pipe. So plug and chug in, of course the total length is just 300 feet divided by the length of one pipe. Just look at over here, it's 6 feet. So divided by 6 feet, you can get, of course, pipe or number of pipes. What are the number of joints now? I just subtract 1 from the number of pipes because we don't need any joints at the end of these pipes, right? I mean, just at the end of sewer line, we don't need any joints, okay? So therefore, I just subtract 1 from the number of pipes. So PEPT negative 1 equals 49 number of joints. And finally, the refilling of trench is required over here. Remember, the excavation is known, the dry budgery volume is also known. So what's the total refilling? Just look at all these dots. These blue dots, of course, just represent the refilling of the trench. I'll just subtract or deduct the volume of pipe and of course the volume of dry budgery from total excavation. So the refilling of the trench is of course the total excavation minus the pipe plus the dry budgery deduction. Let's do some plug and check in over here. The excavation is just 315 OCFT, so 3150 minus the pipe volume. Remember, the pipe is just circular in section, so the cross-sectional area times the length will be just the volume of the pipe, and the cross-sectional area of this pipe will be just the area of a circle, which is pi d squared divided by 4 times the length will make this guy is the volume, plus the dry budgery, which is just of course known as 675 CFT. Let's do some plug and check in for the diameter, and for this length, of course we can get, remember the diameter, I'll take the external one, which is just 11 inches, right? And to convert the 11 inches into feet, just divide 11 by 12, we can get of course 0.9167 as the external diameter of this pipe. So pi times d square divided by 4 times the length is known, which is just 300 feet long sewer line, plus 675, which is the dry budgery. Do some maths with this long thing. Of course, you can get the refilling is 2277 CFT, and the result is over here. First, the excavation, which is 3150 CFT, the dry budgery 675 CFT. How many numbers of pipes are there? Of course, 5 O numbers. The number of joints are just 49, and the refilling of the trench is just 2277 CFT. And this is our approach. Of course, we have done it. Thank you guys for watching. See you next time, and wassalam.